Okay, so let's do a bunch of practice problems with Gay-Lussac's law. Just to review, the law is written like this. It assumes that some sort of change has taken place. So we have P1 and T1, which are the initial pressures and temperature of the gases. Then a change occurs, and then we have P2 and T2, which are the pressure and the temperature after this change. Okay, so here's a practice problem. The pressure in a sealed can of gas is 235 kilopascals when it sits at room temperature, 20 degrees Celsius. If the can is warmed to 48 degrees Celsius, what will the new pressure inside the can be? So we're going to use this equation, and when I'm attacking these gas law problems, the first thing that I like to do is make sure that I know what all my variables are. Okay? So let's figure this out. We have an initial pressure before the change. So P1 is going to be 235 kPa. So we know this guy up here. All right? When it sits at room temperature, so this is the initial temperature, 20 degrees Celsius. Okay? And then the can is warmed to 48 degrees Celsius. So there's our change. We go from 20 to 48. So our second temperature, our final temperature, is going to be 48 degrees Celsius. So we know these guys. And it's going to be P2, the new pressure that we're going to be solving for. Okay? So here are our variables. Now, you may be thinking, you may remember this. Whenever we use gases, we need to convert these temperatures into Kelvin temperatures. And we do that here by taking the Celsius temperature, 20 or 48, and adding 273 to it. Okay? So now before we plug anything in, let's get these Celsius temperatures into Kelvin. Okay? So for T1, we're going to take 273, and we're going to add 20 to it. And so now we're going to have 293 Kelvin for T1. And T2 is going to be 273 plus 48. So this is going to be 321 Kelvin. Okay? So now that we've got these variables all set, let's go about rearranging this equation to get P2 by itself. Okay? So the first thing that I want to do to get P2 by itself is get T2 here out of the denominator. And I'm going to do that by multiplying both sides by T2. Now I have T2 on the bottom here and on the top of this fraction, so they both cancel out. And I can rewrite this as T2 times P1 divided by T1 equals P2. Now, some of you guys might not like that P2 is on the right-hand side, so I'll just flip it. But really, it's the same equation either way. So this way, we'll just say P2 equals T2 times P1 divided by T1. Okay, so there we go. Now P2 is by itself, and we're ready to plug in the variables. Okay, so P2 equals T2, 321 Kelvin, times P1, 235 kilopascals, divided by T1, which is 293 Kelvin. Okay? So we go ahead, we plug that into our calculators, and the answer that we're going to get out, I'm going to round this to 3 significant figures, is 257. Now, what are the units I'm going to use? Well, it depends on what cancels out here. Obviously, we know this is going to be pressure, so we could just say, all right, well, you know it's going to be kPa. But let's just show how we'll do the unit cancels here. We have Kelvin up here and Kelvin up here, down here on the bottom. Okay, so we're going to get rid of the Kelvin, and we're going to be left with kilopascals, which obviously is a unit of pressure. So we know that our final answer is going to be 257 kilopascals. And again, I rounded this answer. My calculator spit out a very long number for this, but I rounded it to 3 significant figures because there are 3 significant figures in each one of the numbers that I started with. Okay? So that's how we do that. let's look at some more. I'm going to look at 3 problems total, and they're each one's going to be a little bit trickier than the one before it. Okay? So here we are talking about a car tire that has a pressure of 2.38 atm at 25.3 degrees Celsius. If the pressure inside reaches 4.08 atm, the tire will explode. All right? How hot would the tire have to be for this explosion to happen? And then report the temperature in degrees Celsius. Okay? So again, we're going to be starting with this equation. The first thing let's do is let's get our 4 variables straight. So we're starting with this initial pressure and this initial temperature, and then we're saying that we're going to raise the temperature, which is going to cause this increase in pressure. Okay? So our initial pressure is going to be 2.38 atm. And our initial temperature is going to be 25.3 degrees Celsius. But remember, we're going to have to end up converting that into Kelvin in a minute before we can use it in the equation. Okay? Now, if the pressure inside reaches 4.08, so that's what the pressure is going to be after the change, there's our P2, 4.08 atm. What's the temperature going to be? How hot would it have to be for the pressure to get that high? So T2 is going to be the variable we're going to solve for. So we know P1, we know P2, we know T1, and T2 is going to be the variable that we're solving for. All right? Now again, let's convert our Celsius temperature here, that's T1, let's convert it into Kelvin temperature so that we can use it for gases. Okay? Again, we take 273, this is T1, we take 273 and we're going to add 25.3 to this. Okay. Now, remember the rules about adding and subtracting with significant figures. We look which of the numbers has the fewest number of decimal places or the fewest significant figures on the right-hand side. All right? This has 1 decimal place. 273 doesn't have any. Okay? So that means I'm going to draw a line down here, and I'm going to round to this digit. I look over here to the 3, so the 8 stays the same. But remember, we have to round using the addition and subtraction significant figures rule. So 298.3, cut it off here, is going to turn into just 298 Kelvin. And that is what I'm going to use for T1. All right? Now, solving this equation for T2 is going to be a little bit harder because it's in the denominator. I'm going to have to go through a number of steps, okay? So bear with me, I'll explain each one. Then after I do this problem out completely in the next problem, I'll show you a shortcut. It's probably a shortcut that your teacher or your textbook hasn't showed you, but it's a way to take all of these steps I'm about to do and condense them into 2. All right, but first I want to show you how to do it sort of the long way, the correct way, okay? So, T2. First thing I want to do is I want to get it out of the bottom. I can't solve for it if it's in the bottom. So I'll get it out of the bottom by multiplying both sides by T2. Okay? So now it's on the bottom here, it's on the top here, so it cancels out, and I can rewrite this as T2 times P1 divided by T1 equals P2. Okay, now it's on the top, but it's far from alone, and we want to get it alone in order to solve for it, okay? So I want to get P1 and T1 both on the other side. I don't know, it doesn't really matter what we do, but let's divide both sides by P1, just for the heck of it. P1 here, and divide this by P1 here, put P1 on the bottom. So now the P1 over the P1, they both cancel out, and I can rewrite this as T2 divided by T1 equals P2 divided by P1. We're almost there. One more step to get T2 by itself. Got to get this T1 out of the bottom here, so I'll multiply both sides. T1 over T1 times this. T1 on the top, T1 on the bottom. They cancel out, and I'm left with T2 equals P2 times T1 divided by P1. Whew! There we go. All right. Now we're ready to plug our numbers in here. So we'll do T2 equals P2, 4.08 atm, times T1, 298 Kelvin, and divide that by P1, 2.38 ATM. Now notice that each of the numbers I'm putting in here have 3 significant digits. So when I put this into my calculator and do the math, the number that I get, the answer I get, I'm going to round that to 3 significant figures, okay? And it turns out that after I put that in the calculator, I round it out, I get 511. What are my units? Well, it depends what cancels out here. ATM on the top, ATM on the bottom, shoop, shoop. They both cancel out. I'm left with Kelvin. So it's going to be 511 Kelvin, all right? And that makes sense because we said that we were looking for a temperature. Obviously, T2 is going to be Kelvin. It's going to be a temperature, but it's still important to cancel these units just so we can make sure that we set everything up carefully. But we're not done. We're not done because the problem asks us to report the temperature in degrees Celsius, not in Kelvin, okay? So let's go back here and look at how we do that. Well, we added 273 to the Celsius to get Kelvin. To get the Celsius, we'll take the Kelvin temperature and we'll subtract 273. So we're going to take 511 minus 273, and we're going to get 238 degrees Celsius. Darn, that's hot. But it's possible. It's possible for a tire to get that hot. It's unlikely, but it's possible. So there is our final answer. We don't have to worry about rounding with significant figures because both 511 and 273 have the same number of significant digits here. So we're set. 238 degrees Celsius is the answer to this. All right, one more problem, and here I'm going to show you how to solve for something that's in the denominator, but how to do it in just 2 steps. So you're going to have to keep multiplying and dividing both sides over and over again. Okay, here's our last problem.